Okay, so you can see it in here. Yes, you can see it in here. The program memory, it has like 8,192 words, and here the SRAM, it is 368 bytes, and EEPROM, it has like 256 bytes. And if we take a look at this, right? So here you can see here RA0, RA1, RA2, RA6, 4, 5, 6, 7, right? So this is port A, right? And here we have port B, and here we have port C, right? And here we have port E. Okay, this is a 886, right? So yeah, we'll take a look at 887. There should be like yes, D port D as well. Here you can see 887, so 40 pins. Yes, it has 40 pins, and out of that 40 pins, 35 of them are 35 of them are inputs and outputs. So here you can see port A, RA0, 1, 2, 3, 4, 5, 5, 6, 7, right? 6, 7. So 8-bit port, right? Then here you have RB0 to RB7, again 8-bit port, and here you will have RC0, C3, 4, 5, 6, 7, again 8-bit port, right? And then you have RD0, RD1, RD2, RD3, RD4, right? RD4. Then you will have a RD5, RD6, and RD7 as well. Is that? Yeah, RD567, and another 8-bit port, right? So it is like 30. Now it is like 32, right? 32. Then you will have RE. Is it 32? RD7. Okay. Yeah, you will have RE0, RE1, RE2. Then RE, RE3. Right? RE3. So for, if you can see that for RE3 pin, we have like here MCLR4. MCLR means this is actually the master clear one, right? So therefore we will take yeah, even though, so here you have A, B, C, D, right? All of them have like 8 bits. All of them have 8 bits, so 8 into 4, it is 32 bits. Then RE0, RE1, RE2, right? So 32, 33, 34, 35, 35, right? So in here, this one says it is 35 input output. So why we say 35 input output is because that master clear is connected to master clear in this one. master, what's that? Yeah, this one, master clear. And so this one, what is this master clear means? If we supply, right, if we supply 5 volts to this, if we supply 5 volts to this, what will happen is so master clear. Okay, I will show you. Okay, so consider this, right? Consider this one for this pin, right? Uh, consider this. For this, let's say we have connected. Let's say this is like 5 kilo ohms or 10 kilo ohms. Say 10 kilo ohms. Then there is a push button, right? There is a push button here, and it is connected to ground, right? So what will happen when I press this push button? It will connect these two ends, right? It will connect these two ends, and then uh, the voltage applied to this will be 0 volts. Right? 0 volts means it is logic 0, right? So can you see that it is MCLR bar, right? So if this is equal to 0, that means MCLR, this is equal to 1. That means master clear is 1. Master clear is 1 means the uh, the memory of this one, right? Uh, the program that will be cleared. This one. So therefore, again we have to load the program, right? But let's say when we are not pressing this, when we are not pressing this, so at that time, here this is 5 volts. So 5 volts will be applied to this. So here this is the resistor and 5 volts will be applied. So there's no connection to this. So 5 volts means logic 1, right? Logic 1. So logic 1 is master clear bar, it is equal to 1. That means master clear, it is equal to 0. So therefore this is 0. So the program that in here, it will be exist, nothing will happen to the program, right? So therefore, always when we are implementing the circuit, right, we should have when we implement the circuit, we should include this part, right? This part, right? Let's say we are not going to reset or we are not going to clear. So at that time also, we should at least have this part. So we should at least have this part. This 5 volts should be connected to MCLR. So therefore, we are not taking RE3 as an input-output pin because of that restriction. So Therefore, I will take here this pins, this pin. So this is port A, right? And this is port B, right? And things and these things port C, right? Then this one, these things port D, right? Then you will take these as port E, right? So like that we will take 5 ports. So in here we have 8, 8, 8, right? Then here we have 3, so 8 into 4 plus 3, it is 35, right? So that's why we call as this as 35 input output pins. So therefore what we should be doing in here is, so if we see our so input output ports, and you see port A, port B, everything it is given, right? And we see uh, that uh, yeah, there are modules, right? So timer 0 module. So we'll take a look at these things later, right? And then look to digital converter. This one we didn't have this option in our PIC16F884, right? And look to digital converter. That means, so if we um, can convert analog to digital, it's in this. So then if we take a look at this in here we have bit oriented and byte oriented and literal and control yeah, can you see instruction sets, right? So these are the instruction sets. Here can you see that mm, um, we had more here, if you can remember this one. So we had this one as well in our previous one. So can you see that so yeah, can you see these things also we have used in PIC16F84. So most of the so here let me see these as well. Most of the things that we have used in PIC16F84 we have here, but addition to that, since this one has additional features, we have more things. So here can you see exclusive RLF, RLF, rotate left F through carry value, then rotate right F through carry, so like that. And here if you can remember, we have used this one. So and here at go to commands and everything we have previously used, and here you can see the instructions as well. So already 1 2 3 4 5 6 7 8 9 10. So like that we have a lot of instructions, and here we have the syntax for that, right? So most of them that we have used in PIC16F884, we have it in here, right? And so here you can see there's everything that we need to know, memory organization, and here can we see that the special function registers, right? Mm. Special function registers. You see that we have bank 0, bank 1, bank 2, bank 3, right? And here can you see that we have the status register as well, right? So previously what we needed was, since we have only two banks, bank 0 and bank 1, we wanted only like one bit, right? One bit, okay, one bit. But actually in here, since we have like four banks, we need at we need two, uh, we need two, right? We need two registers, sorry, two bits. So here we take a look at, can you see? So if we see, this is the status register bit 6 and 5. So here always after this point, right, we will use bit 0. So this is bit 0, right? Here bit 0, and this is bit 7, right? So bit 6 and 5 is these two bits, right? So here when here if we want to stay at band 0, this should be 0 0. That means yeah, this should have 0, this should have 0, right? For bank 1, this should be 0 1, bank 2 1 0, right? Then bank 1, sorry, bank 2, bank 2 1 0, bank 3 sorry, 1 1, right? So that's why we have like this. Right, so can hear me, right? Okay, so what I was telling you, so here we have two bits in order to go uh, between these banks, right? So almost all the commands that we have learned, right? So for pick 16F84, they have valid in here as well, right? So we know how to do or how to work with PIC16F84, right? PIC16F84, right? So using the same principle, right? Using the same principle, so I will give you an exercise, right? I will give you an exercise. So you should try to do that, right? So this is the exercise for this PIC16F887, right? Consider something like this, right? Mm. Consider LEDs are connected. LEDs are connected port connected to port B, right? And port A B0. That means uh, port A first bit, right? So LEDs are connected like that. So for port B, how many bits we have? We have 8 bits. So for that 8 bits, for that 8 pins, LEDs are connected. 8 LEDs are connected. Then for port A, for RA0 pin, right? RA0 pin, that is dot B0, means another LED is connected. Okay, so what should happen is, right, what you have to write is, first try to now this is existing connection, right? Existing connection. So for LEDs, so how many LEDs are here? So for port B, there will be 8 LEDs, and port A bit 0 or RA0, there will be one LED connected, right? So connected means connected to ground. So when you give 5 volts to that, it will switch on, right? So you have to write a program which satisfy this condition. So what are the conditions? When port B is off, it means the LEDs which are connected to port B, 8 LEDs connected to port B, when it is switched off, port A RA0 or port A RA0 pin connected, LED connected to RA0 pin, it should switch on, right? And when port B 8 LEDs are switched on, port A RA0 pin connected LED, it should be switched off, right? And this should happen in a loop, in a while loop, right? So that is your first exercise, right? So therefore, you know how to switch on an LED and switch off an LED from the previous sessions, right? So what I am asking you is to use in micro C, right? Using micro C, try to write a program, right? Try to write a program, right? Try to write a program that will satisfy these conditions. And then what you have to do is you have to open Proteus, then you have to make a Proteus design file which has PIC16F887, right? PIC16F887. Then into that one, for port B, you have to connect 8 LEDs. Then for port A RA0 pin, you have to connect 1 LED. Then you have to put this program which you have written using micro C. Then you have to run it. Okay, so can you give it a try? So there are a few things that you should know. So in order to do this, we can do it by using the same commands that we have used with the PIC16F884. So every command that we have already used with PIC16F884, they are valid in here, right? They are valid in here. So therefore, I expect you to write that program first, right? So if you are not confident about doing this, so first try to write to like switch on and off LED at least, right? So that one, switch on and off LED, that part, so or else just try to write to switch on an LED connected to port A RA0 pin of this PIC16F887, right? So then we'll proceed with this, right? So can you try it? Can you give it a try? So open micro C, right? Micro C Pro for PIC, and then try to write the program inside main. So you have to use a while loop, because this should be a continuous operation, right? So you can copy and paste the things that we have done from the last time, and can you try to do that? I will give you a few minutes. Right, so if you have any question, you can ask. I will be here, right? So I'm here, so you can ask any question you have. So I will show you what you were asked to write the program. Yeah. So in here, go to this, then select pick 16F 887 here. You see. Yes. Yeah. This one we need to select pick 16F 887. Okay. This one. This is what we need. So double click, you will get that. Then we need LED, right? So I'll choose this LED, right? Right. Then I need resistor. So this is the arrangement that you asked to do. Yeah. When we have in this orientation, you can see, right? You can see that yeah, you have array array 0 8 bits, R a port A 8 bits, port B 8 bits, port C 8 bit 8 bits, port D 8 bits, and port E 3 bits, right? Like that we have, right? Then what we need to do is the resistor, right? So we are connecting these resistors. Okay, 8. Right. Then here these values should be changed to 330. 330, and this should be 330. Okay. Okay, like this. So now each and everyone it has like it is 330. Right? So one more this one further, right? Then here connect. Right. Then this one we should connect to no, RS0 pin, right? RS0 pin. Then this LED. So there are like shortcuts. Actually, we can copy and paste, but then the thing is, if these labels are equal, then it will not execute. Right? So then we will connect. This we will connect. Right, then this one is connected like this, and select ground. We will connect each and every one. Like this, right? So what should happen is when this is switched on, when this is switched on, this should be switched off. This eight of this, yeah, eight of this should be switched off. When this is switched on, this should be switched off, right? So switched on, switched off, switched off, switched on, right? So that is what should happen, right? So here this one we are using only R RB ports, port B and port A only one bit, right? So as you can remember, we have done it by making a project and everything. So Can you try to do this for this one as well? So then you have to put the program file in here, then you need to run. Okay, so I'll give you like 5 minutes.
Excuse me, sir. Sir,
So if you have finished making the design file, so
excuse me, sir.
yes, yes.
සර් අපිට බලන්න පුළුවන්ද අර මේ .hex ෆයිල් එකේ තියෙන්නේ මොනවද කියලා ඕපන් කරන්න කලින්?
අපි try වෙන්න පුළුවන්. සෙම්ලි ෆයිල් එක නම් ඕපන් කරන්න පුළුවන්. හැබැයි X ෆයිල් එක අපිට නෝට්පෑඩ් එකකින් වගේ ඕපන් කරන්න අමාරුයි.
Okay, sir.
But yeah, you can try to open it like using a WordPad or something. Okay, try to open that one. So using like WordPad or something. So if you can, so it will be all right. But actually, when I'm looking at here, I haven't opened that one. I was unable to open X file. Okay, so shall we? Okay, shall we move on to how to write the program? So yeah, this one is TC. So I will. So I hope all of you can see this micro C. So I will here. Okay, I will start a new project. Okay. Oh, that's a flash shell. Ed sample one. Yes. I will select that. Then here you have to select PIC16F887, right? P16F887, right? We'll keep the device clock like this. Then on next, so we are not going to add any file. So include all, finish. Okay, then when we try to here okay, build here, so then it asks to save this file name, so we will save it. Okay, then so what we need to do first is we have to make port B all pins port B all pins as output, right? Okay, so in order to that, what is the register that we are using? We have to use tris, right? So we have to use tris B, right? So tris B, right? If we make it equal to 0, right? Make it to 0. So here we can write set port B all, right, as output, right. So each and every um, pin which is connected to port B, now we have configured them as output. So 0 means all 0, right. So 8 pins are now configured as outputs, right. Then but for this A, right, but for this A, we don't need to configure all of them as outputs, right, because there are 8 pins. We need only one specific pin, right. So that is uh, that is bit 0, right, bit 0. Okay, so OR is 0, so therefore we can assign that one, right. We can put dot, right, then we can put P0, right. So this port A equal, right, port A array 0 pin we are making it as output, right. Okay, so we can write as set port A bit 0 as output. Okay, so then what we need to do is uh, so we'll take a look at this one first, then I will explain what we need to do, right. Mm, so what I am going to do is I will do, right. So first we need switch off port B all pin. So at that time I need to switch on port A bit 0. So what I will do is, so port B, right, port B, I want to make all of them as 0. So I will use hex notation. So 0x 0 0, that means, oh, now port B all pins are 0, right. Then I need to make port A pin number 0 or array 0 or bit 0 to 1, right? So equal 1 will make it 1. Right. So now port B all pins are switched off, port A uh, bit 0 or array 0 pin it is switched on, right. Then I need to have a delay, right. So I will make a delay. If you can remember this entire, so ms, so I will use like 1000, right. Now there's a delay. then then what I would do is control C. Okay, so then I will make port B all pins as 0 as 1, right. So that is 255 255 255. If you are writing it in hex, it is FF, right. And at that time I should make this one 0. I should make this one 0, right. And I want to, so now we can see, right. So port B everything is 0. So at that time port A array 0 is 1. Then port B everything is switched on. Port A array 0 is switched off, right. And here this thing should be in a while loop, right. So I will since this should go in a loop, right? So I will use like while one infinite loop, and I will include all of these inside the while loop. Okay, now everything is in inside while loop, right? So if you can see this, we haven't done one thing. What is that? Is if we if we take a look at the data sheet, can you see that? So this is date 7, right? So can you see that tris A is in here, tris B is in here, port A is in here, and port B is in here. So bank 0 and bank 1. Can you see? So we haven't gone between. We first what we have done is we access to tris A and tris B, right? Tris A and tris B. Then then we went to port A and port B. We haven't transferred from here to here or here to here, right? So we need to address that. So it is incorrect, right? So therefore, in order to address this, we have to use this status register, right? We have to use this status register. But actually, when we have uh, uh, when we have this um, when we have like when we are using this actually uh, mm, uh, we, we don't have to move it like this, right? We don't have to move it like this, but let's see if we run this one, right? So what will happen? Okay, so it says it has finished successfully, right? So now what we will do is not what we will do is we will go to okay, we will go to this run. Okay, and then let's try to run this. Now it is running, right? Can you see? It is switched on. It is switched on, and now this is switched on, and this is switched off, right? Like that. So try to do it yourself. So this is the important part. So check whether you got the same thing. So this is a very simple program, right? Any questions? So I hope all of you got the answers. Then okay, so like that. You can we can find then another thing that we should do. So uh, what we have done in here is what we have done in here is actually we have put outputs, right? We have put outputs, not inputs. Okay, we have put outputs, not inputs. We haven't taken any input, right? What we have done is we have taken only we have taken only outputs. We have given only outputs. We haven't addressed inputs, right? So now what we will do in here is we will address inputs as well, right? So uh, I will
සර් අපිට ස්ක්‍රීන් එක පේන්න
okay. I stopped the screen here, so I will share this one. So this is I think you can see this now. So example number 2, what we need to do is uh, switch is connected to switch is connected to uh, port A RA0 pin, right? Right. Okay. When the switch is pressed, when the switch is pressed, what you need to do is you have to uh, uh, turn on the LED connected to uh, port B B0. That means port A pin number 0. So this is what we need to do. Right? So when we address this, Okay, so give me 1 minute to save the Proteus file. Okay, when we do this, so what we are doing is we are taking some input to the system, right? So why we are taking some input? So uh, why we are taking inputs is because that is how we operate. So the whole idea of this unit is addressing the embedded systems, right? Addressing embedded systems. So when we have embedded system, when we give some input, there should be something happen, right? So when we give an input, there should be some actuator triggered. So in this example, what we are doing is uh, we are just considering uh, we are just considering something like this. Uh, but we are considering when this is pressed. Okay, when this one is pressed, when switch is pressed, what we need to do is we need to turn on an LED. So that LED can be some kind of a motor or something. So it can be like that. So some kind of an actuator, right? So that is what we need to address in here. So first of all, I will show you the Proteus Proteus model. So in order to do that, uh, let's start a new design. Right? Okay. Okay. So file, you can see this Proteus one, right? So file, okay, save, and I will first save this 46. So okay, give me 1 second. Okay, I have saved it in 46. Okay. Then I will start sharing. Okay. You can see Proteus screen, right? So again, we have to go to here. This is the component. So component selection. PIC16F887. 887. Double click, it will appear, right? Then we need button, right? There's a button, right? So but we are not going to use this button. This is a push button, right? It's a push button. What we are going to use is a switch. So if you want, you can use a button as well, but for here we will use um, a switch, right? So and we need an LED as well. So I will get yellow LED, right? Yellow LED. Then I need a resistor as well, or else. Okay, then need a switch. I will use this switch. Okay. So then this will be my setup, right? First this, and according to our example, a switch is connected to port A B0 when the switch is pressed. A switch is connected to port A B0, so port A B0, right? That means for this one, switch is connected, and mm, when the switch is pressed, turn on the LED connected to port B B0. So port B B0 means this one, right? So LED should be connected in here, and then here we have the resistor. We connect. Then I need the ground. So this should be. So, this. Then so I will use a switch like this, right? So um, yeah, this is a switch I have, right? uh, what I will do is this. Okay. I will use power. Power pin is this. Then I will use this resistor. Right. So what I need to do is this. Um, right. What I need to do is this. When I press this switch, right? When I press this switch, so I will take ground as well. When I press the switch, what should happen is the value that we are the voltage that we are gaining into this pin, it should be 0. Otherwise, that value should be 1. Right? So something like this. Right? Uh, consider if I connect it like this. Right? So now like this, right? So when I press this, right, when I press this, what will happen is when I press this, the voltage that is going into RA0 pin, it is 0, right? It is obvious, right? But when we are not connecting it to, when we are not connected in here, what is the voltage on RA0 pin? Is it 0 or is it 5 volts? So you can think, you may think that it is 5 volts, but it is not, right? So we are not applying any voltage, either 5 volts or 0 volts, we are not applying. So we this is at float now. Can you understand? So when I put this one, now it is at 0. So 0 volts. Now this RA0 pin is at 0 volts. But if we are in this location, in this orientation, what is happening is we are not applying any voltage on RA0 pin. Right? So therefore, I need to connect this one in here. Can you see? So if I connect this one, when I press the switch, so default it should be, so this is power means we are supplying 5 volts. So from here to here we don't have, this is open circuit, so therefore this voltage which is 5 volts will apply onto RS0 pin, right? But when I connect it, since this has this 10k resistor, this will bear that 5 volts. So from here to here it will be 0 volts, right? So I hope you can understand that. Yes. Default it is at 5 volts. Right. Then let's see this orientation. See this orientation, right? So in this orientation, right? Now default, what is the voltage? By default, what is the voltage on RS0 pin? It is 0 volts, right? It is 0 volts. Default it is 0, right? Because this is open circuit. But when I switch on this, now what is the voltage? Now it is 5 volts. So can you understand the difference? So when I switch this on, that here this will apply 5 volts, and because of this 10k resistor, this won't be short circuited. Can you understand? So now this is at 5 volts. So 5 volts will be bared by this 10k resistor, right? Now default before we are pressing, this is at 0 volts. When I press it, it is at 5 volts, right? So that is the two orientations of the switch, right? So but for our case, what we will do is we will use this orientation. Default it is at 5 volts, right? Default it is at 5 volts. When I press this, it will be 0 volts, right? I hope all of you can understand that. So what should happen is when I press this, this should switch on, right? So that is the basic thing. Okay, so this is the orientation that we have to use. So remember, when we press this will become 0. So when it is 0, when when this is default, it is 5 volts, right? So this is 5 volts. Nothing should nothing will happen, right, for this one. But when I press this, we have planned 0 here on this RA0 pin. When it is 0, this should switch on, right? This should switch on. So that is the necessity. So hope you could understand it. Okay, we'll go to micro C. Okay, can see this, right? So I will start a new project. We'll use input LED. Just one example too. Okay, so then this PIC16F 887 is selected. Then next, finish. Right. And we need to build it, so it has to save. So I will save it. Right. You can do it with me. Right. So we'll do it like this. Inside void main. So first of all, this B0, right? It should be configured as output, right? Then this A B0, we have to configure it as input, right? Because we are giving an input. Right. Then initially, what should happen is port B, right? B0, right? It should be at switched off position, right? Initially, port B with 0 is in switched off, right? So LED should be switched off, right? So then what we need to do is we can use what should happen when port A bit 0 is equal to 1, right? At that time only, right? At that time only, we have to switch on port B bit 0. Can you understand? When port A bit 0 is equal to 0, right? When it is at 0, we have to make port B bit 0 to 1, right? So that is what we need to do, right? So I will put if, right? If uh, port A bit 0 is equal to 0. Is this correct? Is this correct? So inside if we have to use boolean, right? So that means it should be either true or either false. So port A dot B0 equal 0 means it is just equating. So in order to make it boolean true or false, we have to use two equal signs, right? So at that time what should happen? Port V with 0, it should be equal to 1, right? So here we are giving the output, right? then then uh, else port V with number 0, it should be 0. So this is the basic thing. Okay? This is the basic program that we need to write. Okay, but here we need to consider few other things as well, right? That is, here can you see that? Okay, so here this is the switch, right? When we are using like the practical switches, right? Practical switches. Uh, Sometimes when we press it, it may not retain at that position, right? It may not retain at that position. It may just bounce back, right? So it's so as a precaution. So what we are doing is actually we will check whether the switch is at the here this position. This is on position, right? On position for like 10 milliseconds or 20 milliseconds. So if that is in that position, then only we are going to execute this program, right? uh, because we have to be sure that this press is intentional press, so therefore we will put like 10 milliseconds of delay. Yeah, so I will show you how to do that, right? So we will add, right, another if loop, right? If port A with 0, it is equal to 0, so we will check it, right, with a delay of very short delay, right? 10 milliseconds, right? So what we are checking in here is here uh, if switch is pressed, right, then we are checking if switch is still pressed, right? We are checking that. We are checking whether that switch is still pressed. It is an uh, intentional one. So you can understand that because when we are using the practical switches, the practical switches, this may arise because sometimes that switch may not hold at that position at least for 10 milliseconds. So if it is not holding for at least 10 milliseconds, that means it is not an intentional switch on. Okay, it is not intentional switch on. Okay? Then okay, so I put like that. Then this thing we have to write that we have to put everything into while one this infinite loop. So this is this and this is it here. So therefore we'll put that one in this while loop. Right? So now it is almost correct, right? But there's one other thing that we need to look at. That is, that is, here I will show you. See that? So here I will show you this one end cell, and here this one. We have end cell register. So what does that mean is the end cell register, right, must be initialized to configure an analog channel as a digital input. Pins configured as analog inputs will read 0, right? So what we are doing in here is actually what we are doing in here actually this end cell register, right? We have to configure this end cell register as 0. Here we have to configure this end cell register as 0. Why is that? Because okay, uh, is used to configure the input mode of an IO pin to analog, right? And so here we are giving the input in here, right? If we see this one, are we giving a digital input to analog input? This is 5 volts, right? What we are getting is 5 volts or 0 volts. So first this is 5 volts, right? When I configure, like when I press it like this is 0 volts. It is 0 volts, right? So it is a voltage that we are giving, right? It is a voltage that we are giving. So that voltage it has to take it as either 1 or 0, right? This pin, it should read this as either 1 or 0. This pin should read it as analog or digital, right? Analog means it will read the continuous value, right? Continuous value means, so when I press this may not be at exactly at 0 volts, right? It may be at like 0.1 volts. So this pin should not read it as 0.1 as an analog value. This pin, it should read this one as a digital value, so 0.1. So like this. Where is that? Okay, it's be something like this, right? So yeah, this is 5 volts and it is 0 volts. So analog read means we are reading any value. So let's say 0.02, the voltage is 0.02, 0.2 volts. So then if it is at analog, it will read 0.2, right? 0.2. But here this is the limit 2.5 volts, right? When it is configured as digital, all the values between here and from 0 to 2.5, it will read as 0, right? And read it as 1. Okay, so we need to do that one in here, and in order to do that we have to use the AND cell register. Right. So what we need to do is we have to use this AND cell register. So AND cell register, 0, right? We have to make it as 0. So what we are, our intention in doing this is set RA0 as analog read, right? It should be read as that analog value. It should be read as a digital value, right? So that is what should happen. So uh, because when you are working with this, sometimes it may not give the exact value, right? If it is 0, it will not give the 0. If it is 5 volts, it will not give 5 volts. It will give like 4.9, so something like that. So let's try to build this thing. Okay, it is finished successfully, right? Then we'll go in here, program file, so input telnet. Okay, now we'll run. Here can you see the switch on, switch off. Right. Okay, so let's see. Okay, so I have here set RA0 so in this so this is where we give this value, right? Okay, so let's see 5 build and program this, right, without this part. If I go to it, it will work, right? It will work fine. Why? Because this is simulation. In simulation everything works fine. Can you see that here default is it doesn't matter the program. Here default it is red color. That means it is 5 volts applied. When I press it, it applies 0 also, like that. Okay, so that if statement is connecting these 2 points, so this will work fine even though if I don't add this if statement, right? But when we are using it practical situations, we we need to add this if statement, because otherwise otherwise it will not work properly because of the practical difficulties, right? So therefore always we should keep that very small delay. Can you see like this, right? Because in practical switches it may not stay at this place always, right? It will change. Okay, because of that, right? So those are the examples. Those are the examples, and uh, here what we have learned today. So if we are trying to write this one uh, using like MP lab, this will take so many hours, right? Why? Because we have to write, even we need to write that moving between the banks as well, right? Actually we have like bank selection, bank cell command. Actually it is called bank cell, so sometimes we may use it, right? But for this one we don't have to, so we have used only these commands, right? So you can see, right? So like that we can do, we can take inputs, right? So when we are taking an input, so we are giving that 0 volt, so we are taking that as, so here uh, analog we are reading as digital, right? So because why? Because when I read it in here, I am going to, sorry, when I am read it in here, I have to take yeah, this value is digital value, so 0 it is a digital, so I am comparing it with the digital value, right? So that's why, so it should be a digital value, otherwise I cannot uh, equate this, because this command will execute only if it is 0 only. 0 only means if it is digital 0 only. Can you understand? So that, and here if we connect the switch in otherwise, right? Otherwise means the other way around. So default is 0, then when we press it, it is 1. Then you have to adjust, this, right? So when it is 1, this thing should happen, right? Okay, so this have to change and this have to change, right? Like that. So that is how we should write in. Any questions? Any questions from the things that we have covered up to now?
excuse me sir,
Yes.
මේ
Oh,
මන් ලියපු එකේ සර් ස්විච් එක රන් කරාට පස්සේ ඔන්න වෙලාම තියෙනවානේ මේ ලයිට් එක, මේ LED එක ඔන්න වෙලාම තියෙනවානේ මේ ස්විච් එක ඔන් කරත් ඕෆ් කරත්.
මෙතනද?
ඔව් සර්.
අපි බලමු මේ ස්ටේට්මන්ට් එක මොකද වගේ මේ මෙතන මේ equal sign දෙකක් දැම්මද බලන්න. equal මෙතන equal sign දෙකක් ඉන්නවා. ඒක දැම්මද?
ඔව් සර්. රයිට් ඕකේ සර්. ෆෝල්ඩර් එක හොයාගත්තා.
මොකද නේද?
ඇන්ඩ් සෙල් එක මේ 1 කියලා දාලා සීරෝ නැතුව.
එතකොට ඇන්සල් එක 1 කියලා දාපුවම මොකද වෙන්නේ? මේ එයා එතකොට ඒක රීඩ් කරන්නේ ඇනලොග් වැලියු එකක් විදියට. එතකොට ඇනලොග් වැලියු එකක් විදියට එයා රීඩ් කරොත් එතකොට එතන වැලියු එක එක්සෑක්ට්ලි 0 වුන් නැත්තම් මෙයා මේක එක්සිකියුට් කරන්නේ නැහැ. එතකොට හැම වෙලේම මේක ඩිෆෝල්ට් මේ ඔන් එකේ තියෙනවා. right? මොකද මෙයා මේක රීඩ් කරන්න ඕනේ මේ ඇනලොග් වැලියු එක ඩිජිටල් වැලියු එකක් විදිහට රීඩ් කරන්න ඕනේ. එතකොට විතරයි අපිට මෙන්න මේ if ස්ටේට්මන්ට් එකේ ඇතුළේ ටික එන්නේ. right? Like that. So
ඕකේ සර්. තැන්ක් යූ සර්.
anything else?
එක්ස්කියුස් මී සර්.
Yes. Yes. ඔව් කියන්නේ.
සර් මම මේ ප්‍රෝටිය software ඉන්ස්ටෝල් කරා සර් ඒක මේ auto වෙනවානේ like after 2-3 minutes නිකන් close වෙනවා software එක. solution එකක් නැද්ද සර්?
මොකද ප්‍රෝටී software එක මොකද වෙන්නේ වගේ ඒක
ඒක නිකම්ම close වෙනවා සර්. after like 2-3 minutes නිකම්ම close වෙනවා සර් ඒක.
සමහර විට ඔයාලට තියෙන version එක එක්ක බලපුවාම මේක මොකක් හරි අර crack එකේ මාකර ප්‍රශ්නයක් හින්දාද දන්නේ එහෙම නැත්තම් මෙතන මේ ඔයාලට පුළුවන් මේ අර Proteus portable version එක download කරන්න තියෙනවා මම use කරන Proteus portable එකක් ඒ කියන්නේ මේක අර install වන files ටිකත් එක්ක තමයි මෙතන තියෙන්නේ. ඒතර මම මේක open කරද්දී open වෙන්නේ මේ file system එකත් එක්ක. එහෙම එකක් use කරන්න පුළුවන්. එතකොට අපිට මේක install නොකර පාවිච්චි කරන්න පුළුවන්. Let me show you. Yeah. software එකේ මෙන්න මේ Proteus 7.7 portable එකෙන් මෙතන තියෙන්නේ මේක මේ install වුණ folder එක තියෙන. ඒතකොට මම bin එකෙන් කියලා මෙන්න මෙහෙම එකක් open කරන සමහරලාට අර crack එක හරියට නැති වුණොත් මේ වගේ එකක් use කරන එක ලේසි. ඒතකොට අපිට install නොකර පාවිච්චි කරන්න. හැබැයි මේ file එක ටිකක් ලොකු size එකක file එකක්. මේ කාන වගේ තියෙන ෆයිල් එක. එහෙම යූස් කරන මොකද Proteus එකේ අර සමහරලාට වල යූස් කරන මේක ලයිසන් නැති එකක් යූස් කරන ක්‍රැක් එකක් වුණොත් එයා මම හිතන්නේ ඔටෝ ක්ලෝස් වෙන හරි මොනවා හරි එකක් දාලා ඇති. Anything else? I suppose that I can understand these things. So like that for any PIC we can do these things, right? So actually when we are like connecting it in actual cases for this MCLR also we need to do some connections. So something like default. So as I told you, default it should be at 5, right? So then Accidentally I closed Proteus, so let's open it again. Oh, it is not saved or something, right? Actually, what I want you to do is actually you can saved. No. Okay, so okay, so yeah, when we are using it like in a real world, so we have to use this setup because as I told you here, this should be always at +5, and this should, when we press it, this should master clear everything. So uh, this part is sometimes is added in there, right? So that's why um, master clear. So therefore, actually, when we have it like this, so we cannot actually take R3 as input and output pin. So that's the thing. Okay, so if any questions? Any questions that you want me to answer, or any doubts or something? I will stop the recording.